In this video, we'll be looking at Heap program for C language. So in this program, I will be writing a function for inserting as well as deleting, as well as I will show you heap sort. So let us call this as heap. Create a program. So a new project is created. So as we have discussed, for implementing a heap using an array, we will take an array, and size I will not mention. Directly I will initialize some elements. See, the 0th index, we are not using it, so I will skip that one. So for that I will set it as 0. Now rest I will set the elements. So total 8 elements I have taken, including 0. So the array size is 8 and I have only 7 elements in a heap. These are the elements in a heap. 0 is ignorable. We will not be using this location at all. Now I have randomly taken some elements here. Now let us write a insert function for a heap. Void insert. It should take an heap array as well as the element index of an element that we want to insert. So let us call the index of that element as n. So here inside I will take some variables, that is I starts from n, and also one temporary variable. Then that temporary variable should have a of I value. That is what we have to insert in a heap. Now we have to compare and switch the element or swap the element until it reaches root or until it fits in its right place. So for that we have taken a while loop while I is greater than 1 and the temp is greater than a of I by 2. So we'll be comparing it to parent, and if it is greater than parent, then we will copy the parent value. If it is greater than parent, then we will move the parent. So at a of I, we will copy the element from a of I by 2. Then I should be moved to parent. By 2 will make it move to the parent. And finally, when we have reached at the last place, means we got a right place for this temp element that we are inserting, then we will copy the element at a of I as temp. That's all. This is insert. Now, as already I have taken some elements in an array, I can insert them one by one. So first I will insert 5 in a heap. So right now heap is having only one element, let us say 2. Then I will insert 5, so 5 will go on this side. Then 8 I will insert, then 9. So let us see what will happen if I insert all these elements one by one. So let us call insert heap, and first element that I will insert it as index 2. So here I'll mention index 2. Then I'll copy this and paste it, and next I will insert an element at index 3. This I can do it using for loop also, but I just want to show you step by step. Just see what happens. Then fifth index. So let us check till here what happens. So I am inserting 5, 8, 9, 4 and 10. So here I'll put a here I'll put a breakpoint, then I will run. Oh, there's a mistake. Yes, here I have given the name of an array as h. Okay, I will change the name to a. Here the parameter was h, but I was using a. Now it's perfect. So you can watch in this debug area. Right now array is containing the element 0, 2, 5, 8, 9, 4, 10. So if I continue executing, 5 is inserted first, so 5 should come at the place of 2. Yes, 5 has came at the place of 2. Next element to be inserted is third element, that is element 8. So it will come up to root. So yes, you can see that 8 has came into root. The next is largest element 9, so it will come in the root. Yes, 9 has came in the root and 8 has become its left child and 5 is the right child. Then 4, when I inserted 4, 4 remains in its own place. Yes, 4 has remained in its own place. So you can see that the elements are inserted in a heap one by one. Right now this array is not a heap, but by inserting these elements one by one on the left hand side, this is forming a heap. I'll remove this breakpoint. I'll stop the program. I will insert all these elements one by one using a loop. So let us take a variable I, and using for loop, I will insert the element. So I have to insert the element from second element onwards. So I is less than or equal to the last index is 7, then I plus plus. So here instead of 2, I will take it as I. So only one insert function is sufficient because it will be repeated using for loop. Now this will be inserting all the elements one by one. Here I will change the values. The one I will take the example that we have already seen on the whiteboard. That is a program for creating a that is a procedure for creating a max heap. So I will write down the same set of values that are 10, 20, 30, 25, 5 and 40 and 35. Yeah, these are the elements that I have taken on whiteboard. Then after forming a heap, these are the list of elements that I should have in an array. When that are converted into a heap, I should have the elements like this: 40, 25, 35, 10, 5, 20 and 30. This is what the result should be. Once this has converted into a max heap, then the array should have these elements. So I have changed these elements that I have taken the example from the whiteboard. So I have changed these elements. I have taken the same example which we have seen on whiteboard for creating a max heap. So let us run this and see. I should have the elements sort arranged in this form. So for that, I will use a for loop for displaying all these elements. So I will display all of them. For index starting from 1 onwards, I is less than or equal to 7, then I plus plus. Let us print them. Percentile D, that is h of I. And at the end, a new line. Let us run this. Yes, I got the elements in the same order. See, this has formed a Yes, I got the elements in the same order. This has formed a max heap. Now next, let us look at a function for deleting one element from a heap. So here I will write a function for delete. Delete function should take an array. I'll give the name as A and the number of elements, that is size of heap, the exact size of heap. We need the last index. Now I need some variables I, j and x. So x assign the element that we want to delete is a of 1. The first element will be deleted. We cannot delete any other element from heap. In x, I will take the last element, that is a of n, the last element, and at the first location, I will copy the element from the last location, that is x, that I have taken just now. So the last element is copied at the first place, then I should start from first element, that is what we have to adjust, and j should be pointing on left child of I, that is I into 2. So this is the left child of I. Now we have to adjust this element. For adjustment, we will run a while loop while j is less than n. Now, as we have reduced one element, the size of the array, that is size of the heap, has reduced by 1, so it is j minus 1. Then every time we have to check whether the left child, that is where j is pointing, or the right child, who is greater. So here I will check if a of j is So here I will check if a of j plus 1, that is the right child, is greater than the left child currently wherever j is pointing, then move j to next location, that is j plus 1. Let it point on the right child. Then check the parent value where I is pointing and the value of a child where j is pointing. So if a of I is smaller than a of j, then interchange these elements. So for interchanging these elements, I need a temporary variable. So I will take some temporary variable. Then a of I is copied in temp. Then in a of I, copy the element from a of j. Then in a of j, copy the element from temp. So this all swapping is done. Then I should come upon j, that is the child, and this j should move on to left child, 2 into j. This will go on the left child. That's all. And if I is not less, means it is properly adjusted. So simply say break, that is stop the loop. That's it. And here I have used one more variable, that is temp. So I have declared a variable temp. Now the value that we have deleted was a1. So I have not taken it in any variable. So let us declare one variable val, and in that val, that is deleted value, we will take the value from a of 1. So this is the deleted value. And at the end, I will also return val, that is deleted value. That's it. So the same code I have written, what I have explained on whiteboard. So let us see whether it works. So after creating a heap, I will perform delete operation. So directly I will call it in printf deleted value is %d, a new line, call delete function by passing heap array, and the number of elements are 7. Then so right now, after forming a heap, the root element will be 40. So 40 should be deleted. And inside this delete operation, we are arranging the deleted element at the last, that is at this index. So here we should get 40, and these elements must be forming heap. So this 40 is deleted and it should be copied at the last place, and the rest of the elements must be forming heap. Let us run this. Yes, deleted element is 40. Okay, new root is 35. Oh, this 30 is still there. This is not replaced by 40. So let us check in the code. We have copied it there. Yeah, last element we brought it here, but we did not copy this first element at last place. So I will do that one also. After copying this, I will say a of n should be assigned with the deleted value. Now let us run this one. Yes, 40 is copied at the last place. So this delete function is deleting an element, and also it is keeping the deleted element at the last place. Let us try to delete one more element. I'll copy this and paste it. And now the heap size is not 7, heap size is 6. So let us run this now. 35 should be deleted. Yes, first time 40 is deleted and the second time 35 is deleted. And the heap is from 30 to last element is 5. And these two elements, 35 and 40, the deleted elements are arranged like this. So that's how the elements are deleted. Now I will call a delete function using a loop. So I will delete all the elements one by one. So for I assign n, that is 7, n is 7, and I is greater than 1, I should stop when it has become 1, then I minus minus. And call delete function by passing heap and I. Then afterwards, I will display all the elements. So let us see what happens. Oh, elements are sorted. Yes, that's it. This is heap sort. So heap sort, you can see that insert all the elements one by one in a heap and delete all the elements one by one from heap. And inside this delete operation only, the deleted elements, I am storing them at the last place, that is free space in an array. This is the statement which is storing the element at the last place. So that's all about heap sort. So you can practice this program. So that's all. This is a program for max heap, and also it is for heap sort.